Hello everyone, I am Deepashri. Welcome to my maths channel. I am discussing about 10th standard real number. So I done two parts for introduction. So in that part 1 today we are going to discuss. So in real number, to know what is real number, we have to learn some basic numbers like natural number, whole number, irrational number, rational number and composite number and prime number. Okay. Now what is natural number? Counting numbers are called natural number. So counting numbers like n is equal to 1, 2, 3 and so on. These 1, 2, 3 and so on. These numbers are called natural number. So starting from 1 and it has no end. It is denoted by n, capital N. Next, whole number. So what is whole number? 0 along with all numbers are together called whole number. Means this is similar to the natural number, but you should include one extra number, that is 0. If you included 0, then it is a whole number. You can see W is equal to 0, 1, 2, 3 and so on. So the number starts from 0 and it has no end, which is called whole number. Next, integer. Integers denoted by I or Z. All numbers from -3, -2, -1, 0, 1, 2, 3 and so on are called integers. So along with the whole number, so here whole number is 0, 1, 2, 3 is a whole number. So along with the whole number, there is a negative numbers like -1, -2, -3 and so on. So this is called integer. Next, what is real number? All rational and irrational numbers are called real numbers. So the chapter name is real number. So what is real number? All rational and irrational numbers are called real number. So let us learn what is rational and irrational number. Rational number. Rational number is denoted by Q. Real numbers of the form P by Q, where Q is not equal to 0. So the numbers which are in the form of P by Q is in the fraction form like 3 by 2, 7 by 8. So these all are rational number. So Q should not be equal to 0. Means denominator should not equal to 0. For example, 2 by 0 is not a rational number. So these are the rational number which should be in the form of P by Q, where Q should not be equal to 0. And all integer can be represented by rational number. So some integers like -3, 5, these all are integers. So how you can represent it by a rational number? So -3 by 1, 5 by 1. You can write -3 as -3 by 1, which is in the form of P by Q. So that can be represented in rational number. Next, irrational number. It is denoted by Q dash. Real numbers which cannot be expressed in the form of P by Q. So the irrational number you can't express it in the form of P by Q, and whose decimal expansions are, and the irrational numbers decimal expansions are non-terminating and non-recurring. Its decimal expansion are non-terminating and non-recurring. So you know what is terminating? Terminating means it has end, but non-terminating means there is no end. After decimal expansion, if you consider decimal expansion, it has non-terminating. So non-terminating means this goes on. It has no end. After decimal expansion, whose decimal expansion is non-terminating. Similarly, non-recurring. Recurring means repeating. So non-recurring means not repeating. So the numbers are not repeating. So you can say repeating means 3, 3, 3 like this. This is repeating, right? 3, 3, 3. So this is not non-recurring in this irrational number. So some example of irrational number are root 2, root 3, root 5 and so on. Pi is also irrational number. So root 2, root 3, root 5, if you see the value of root 2, root 3, root 5, you can get the value whose expansion, decimal expansion is non-terminating and non-recurring. Prime numbers is greater than 1, the natural number which is greater than 1 and it is divisible by 1 and number itself. So the number which is only divisible by 1 and number itself. For example, you see 2 greater than 1, so you should start from 2. 2 is divisible by 1 and the number itself. So you know that 2 ones are 2 and 2 and 1 2s are 2. So only 2 is divisible by 1 and number itself. Similarly, if you consider 3, 3 ones are 3, 1 3s are 3. So again you see that 1 it is divisible by 1 and number itself. So these type of numbers are called prime numbers. So 2, 3, 5, 7 and so on. This is a what? Prime numbers. Here composite number. So divisible by 1. So composite number is divisible by 1 and number itself and any other number. There is another option, it is divisible by any other number. So this is composite number. So you can take 4. So 4 ones are 4, 1 4s are 4, 2 2s are 4. So it has 3 factors, right? 1 it is divisible by 4, 1 and 2. So if there is more than, here only you can see 2 factors, 2 and 1, here you can see 3 and 1. So here you can see more than 2 factors like 3 or 4, 5. If you consider 16, so it is 4 4s are 16, 1 16s are 16, 16 1s are 16, 2 8s are 16, 8 2s are 16. So this has more than 2 factors. So these type of numbers are called as composite numbers. So 16 is composite number, 4 is composite number and other than that 4, 5 is not composite number, it is prime number. 6 is a composite number because it is divisible by 1, 6 and 2 and 3. Similarly 7 is a prime number, 8, 9, 10 and so on. This is all our composite number. Note, you have to note that 1 is neither prime nor composite because prime number should be greater than 1 and you know that prime number should have 2 factors, that is divisible 1 and number itself are the 2 factors, and here in composite number it should be more than 2 factor. So 1 has, it is multiple of only 1, 1 ones are 1, so it has only 1 factor, therefore it is neither prime nor composite number. Theorem 1.1 Euclid's division lemma. So Euclid division lemma will applicable to find HCF. So this is based on divisibility. Given any 2 positive integers a and b, there exist unique integer q and a satisfying a is equal to bq plus r, 0 is where r is greater than or equal to 0 but less than b. So let us discuss this statement by taking some example. So let us take given two positive integer a and b. So let us take 2 positive integer, that a is equal to 455 and b is equal to 42. Let us take a is equal to 455 and b is equal to 42. So if you divide this 455 by 42, so you know that 42 tens are 420 So the remainder is 35. So here you can see there exists a unique integer q and r. So while you divide that, if you take two positive integer, if you divide this, you get two unique integer, that is q and r. So this is what quotient, which is called as q, and this is what remainder, which is called as r. So here 455 is what we took, a, and this is b. And well, after this, satisfying a is equal to bq plus r. So satisfying the equation a is equal to bq plus r. So if you want, we can check. So what is a? Write down the formula. A is equal to bq plus r. So what is a? 455. What is b? 42 into q is 10 plus r is 35. So that is 42 tens are 420 plus 35, which gives same 455. So this satisfies a is equal to bq plus r, and the remainder is always less than b. Less than b is nothing but b is 42. So this may be 31 or 30, 28, 27, 1, 2 till it will till 41. So this is always r is less than b and greater than 0. It will not be 0, greater than 0. So this is what Euclid's division lemma.